As promised, I'm going to go over the commands that we focused on in the last lecture. The video from the last lecture didn't come out, even though the audio did. So what I'm going to do now is re-record the important things, sort of distill what it is that we went over, and just focus on the most important things. So this should be considerably shorter than the lecture, but it should still cover all of the important topics. So in the DATS 6102 folder, there will be a file called Commands for Review. And what I suggest you do is copy that file into your home folder. Or if you're in your home folder, do cp space DATS 6102 Commands for Review, and then copy to your home folder. So in your home folder, you'll then have this file, and you can follow along. So, yeah, first things first. What we did first last night was review data mining. So using some of the tools that we've learned so far to grab some data. One website that we focused on in particular was the NOAA website. So here is the NOAA website, and there are 14,000 plus files here. And the goal here was to basically write a script that will download all of these files for us, so that way we don't have to go ahead and download them. And the way that we did that was, well, the first thing we did is we grabbed that file. Now I'm commenting this out because I don't want to go ahead and, well, I suppose I can grab it again, but it may take a while to go ahead and pull down the entire web page. But once you do pull down this web page, you can dump the web page, and here's what you'll see. So if I put this in the head, I'll see that I have some header information here. And then about 9 or 10 lines down, I start getting that payload, the URLs to the files that I want to download. And if I tail this too, I'll see that I also have some footer information. That's not really interesting to me. So what I'm going to do is I'm going to use grep, and I'm going to grep on a pattern that I find in all of the lines that have that the URLs that I want to extract. So for example, I could grep on a href, but the pattern that I chose to grep on was just the following. So now when I do this, let me put this in the head, I see now that I'm filtering out the header information and the footer information, and I have only those lines that I want to keep. So now what I'm going to do is I'm going to use awk here. Actually, I'm going to keep head there so I don't fill the screen up with data. So now what I'm going to do is I'm going to use awk, and I'm going to use the split function. So recall, split is a function that takes 3 arguments. The first argument is going to be the input data, and that's going to be the entire row. The second argument is going to be the name of some array, and I can think of any name I want, and to illustrate that point, I'm going to use the name Glenn. And then lastly, I need to specify what character to split on. Now I'm going to be splitting on the quotation mark, the double quotation mark here and here. Now, what's significant about this is that the double quote is a reserved character in awk. So in order to split on a double quote, what I have to do is I have to escape it using the backslash character. Otherwise, if I just did this, awk would think that, well, I'm splitting on nothing and I just have some extra quote here dangling doing nothing. I've split my lines, and what I can do is I can print Glenn, and so the first element is going to look like the following. The second element is going to look like so, and actually that's what I want to keep. And the third element, just for completeness, is going to look like this. So yeah, it's the second argument, it's the second element of the array that I want to keep. And now what I'm going to do is I'm going to preface the second argument of that, I keep saying that, the second element of that array with wget. And I'll put a space in there too. So now I have I'm getting each individual data file, and I'm doing it for 10 files because, of course, I'm filtering down the entire file size using head here down to 10 rows. And what I can do then is redirect that into something called, let's call it download list. And then I can use bash download list. Well, maybe I should show you what's in download list. It's just this. And then I can use bash. Oops, that's not right. Well, I just called it down list. And now I'm going out and I'm retrieving all of those data files. So that's the first thing that we wanted to look at. That takes us through this section here. The next thing that we wanted to look at was using the if statement. So I showed two examples. I showed if by itself, and I also showed an if-else example. So let's take a look at the first if example. So I'm using the netstat command, and just to remind you what netstat does, let's put this in the head, just to give me the first few lines. So what netstat does, it gives me information about all of the open network connections to our server. .6102. Now, suppose we have a table, and we just want to add more data to this previously existing table. In that case, we want to eliminate the headers. So what I'm going to do is I'm going to execute an awk statement using an if condition. So what I'm going to do is I'm going to what I'm going to do is pipe netstat into awk, and I'm going to use the if condition. If the number of rows is greater than 2, then execute this code block. So that's going to print the entire row. If the row number is not greater than 2, then it's not going to do anything. So let's see how that works. And that actually works great. So my header information is gone. So the next, now we want to take a look at if-else. This example is pretty much the same as before. If the number of rows is greater than 2, print the entire row. However, if the row number is not greater than 2, then we're going to give it something else to do using the else expression. So when the row number is not greater than 2, we don't execute this code block. We then go to the else statement and execute this code block. So now what we should see is the netstat command, but the header information now is going to be replaced with headers here. And indeed, we see that that's the case. This next example was a little bit more involved. Here we're going to be using a for statement. The for statement, similar to the split function, takes 3 arguments. We take an index, in this case I, which we initialize to 1. We then set a condition. As long as this condition is true, the for loop will continue to cycle. So, as long as I is less than or equal to the number of fields, continue the for loop. Of course, once I is greater than the number of fields, this condition is no longer true, and the for loop exits. The third argument to the for function is the increment. It tells I how to change with every loop. In this case, we're going to increment I by 1 every pass through the loop. So, here's our code block for our for loop. It begins here, and get out of there. It begins here and ends here. So this highlighted expression is what's going to be repeated over and over again. In the for loop, we have embedded an if statement and also a new function, the printf statement. So let me go over the if statement first. Basically what we're saying is, if I is not equal to the number of fields, basically if I is not the last column, then execute this code block. Otherwise, execute this code block. So now both of those code blocks contain the printf statement. So I need to tell you how the printf statement works. Essentially, printf is divided up. It's a function, so it begins and ends with parentheses. And it essentially has two pieces. The first piece is the piece that is sandwiched by double quotations. This is what's going to get printed to the screen. So here I have %s, which is a placeholder. I'll come back to that in a moment. And then the pipe character. The next piece of printf is the list of variables. It's a comma-separated list, and in this case I only have one variable, so, well, there's really nothing to separate. Now, what does this %s do? What does this placeholder do? It says the following. It says, whatever value is being stored by $i, which could be the first column, the second column, the third column, etc., insert that here. That's what I mean by a placeholder. So what this printf statement is going to do is take the first column, print it, followed by a pipe, take the second column, because this is a for loop, take the second column, print it, follow that by a pipe, and so on and so forth, all the way until we get to not quite the number of fields, but one less the number of fields. Well, what if I is equal to the number of fields, if I is equal to that last column? Then we're going to print out something a little bit different. We're going to use the same %s placeholder and the same pipe, but in this case we're going to use we're going to add a new line character shown here as \n. And then lastly, in order to make this a little prettier, I put it into column. But let me show you what it looks like without column. Now let me show you what it looks like with column. And I'm collimating on tab characters. So now it looks nicely formatted. Now, what would happen if I ran that same command, but I removed the new line character? So essentially, now the second printf is identical to the first. What would that look like now? So now it looks like one long run-on line, because there are no new line characters at the end of every listen pipe, listen pipe, listen pipe. One other thing to look out for when using printf to print columns is we want to make sure that the variable that we're printing is not I by itself, but it's rather $i, indicating that we're taking the value of a column and printing it where the string placeholder goes. Now, there was another solution that's a little bit simpler and probably bears taking a look at. In this solution, we don't use the if condition. We simply write out all the columns, including the last column, and then at the very end, we print a new line character, which you can see split across the lines here. And that gives you the same output. We're going to continue on using the netstat example to show how you can use awk to write well-formatted SQL scripts. So, as before, I'm starting with netstat and I'm piping it into awk. I'm also skipping the first two rows because those are headers and I don't need them. Now what I do is I'm going to use the print command, and I'm going to print this literal string. Insert into netstat table values, assuming I have a netstat table, the values, and then I open a parenthesis. And now recall, in SQL, the value list has to be separated by commas, but each value has to be sandwiched by single quotes. Now, awk doesn't handle single quotes very well. In fact, every awk program begins and ends with a single quote. And so if I were to just throw a single quote in here, awk would think that I'm trying to signal the end of the line, the end of the code, in fact, which is not what I'm trying to do. And it turns out that even using the backslash single quote character won't help. The only way to get around this is to use the ASCII encoding for the single quote character. The ASCII encoding for single quote is \x27. So wherever you see a \x27, a single quote will be written. So now, we read this as insert into netstat table values, open parenthesis, single quote, close that string. Now print the value in the first column. Open up a new string, which is going to be single quote, comma, single quote, close that string. Now print out the last column. Open up a new string, print a single quote, comma, single quote, close that string, and now print out the second column. I realize I'm sort of going out of order here, but it doesn't really matter. Single quote, comma, single quote, close that string, print the value of the third column, open up a new string, single quote, comma, single quote, and so on and so forth until we get to the end. In fact, let me just clean this up a little bit. I'm going to get rid of the last line here, this guy. So that's a brute force way to do this. That's perfectly fine, although the problem with this is, notice that I've hard-coded the number of columns into my awk script. So if the number of columns at some point changes, I have to go back and rewrite this little awk one-liner. However, I can do this programmatically in such a way that even if the number of columns does change, I will be able to account for that. I can write this in such a way that even if the number of columns does change, awk can take account of that. How? Well, we're going to do this programmatically. And as before, I start with netstat, pipe into awk, skip the first two rows because that's header information. And now what I'm going to do is I'm going to use the printf statement. I'm going to printf, oh, and by the way, the reason I'm using printf here is that printf doesn't insert a new line character the way print does. In fact, the only way to get a new line character into printf is to explicitly place one. So I'm going to use printf. I'm going to use printf to write the following string. Insert into netstat table values, open parenthesis, single quote, and then I'm going to end that string. Notice that I don't have any placeholders in my printf statement, so I don't need to specify any values to insert into those placeholders. So that's the first part of my awk script. Now what I'm going to do is open up a for loop. For j is equal to 1, as long as j is less than the number of columns, j++. And now what I'm going to do is I'm going to use printf. I'm going to have a placeholder here, a single quote, comma, single quote, and then I'm going to end that string. Now I'm looping over j here. So $j is going to take on the values of the first column, the second column, the third column, all the way up until the very last column -1. Lastly, that will get me 5 columns. Lastly, what I'm going to then do is use printf, print the last column, open up a literal string, print a single quote, close parenthesis, semicolon, because every proper SQL line ends in a semicolon, and then I'm going to finish that for block. And then I'm going to close that if statement. Notice I get the same result, but this way of doing it, that is doing it programmatically, is a little bit more complicated, sure, but it's much more general. It can adapt to a wider variety of situations. If the number of columns changes, I don't need to rewrite my awk script. That brings us to the end of our review. I've decided to not include this section on the exam, so you don't need to worry about it. We'll pick that up again in the next lecture.